Welcome in the name of IRISCC to this third session on the webinar series related with the research infrastructures concerning IRISCC. As you know, IRISCC aims to integrate climate change related services from 14 different European leading research infrastructures. And today we do have the pleasure to have with us Chiara Cagnazzo from the ECMWF, which stands for the European Centre for Medium Range Weather Forecasts. And also we have the pleasure of having Ville Tengnen from the EGI, the acronym. It was originally coming from the European Grid Infrastructure, but it has evolved from that time onwards. So he's going to explain us what's in the EGI for IRISCC. Just move forward. Yes, as in the previous sessions, and you have probably noticed, we're going to be recording these parts of the webinar for dissemination purposes, and we're going to put it in our IRISCC YouTube channel. But we're going to, after that, stop our recording for the questions. And in this webinar, we have approached the speakers once again, asking for these three questions. What is this research infrastructure you are talking about? And how is this research infrastructure fitting in the context of IRISCC? And if they can give us some climate change risks related cases in relation to their research infrastructures. So we are going to start alphabetically, and therefore I'm going to give the floor to Chiara. Chiara, whenever you want, the floor is yours.
Thank you very much. I think you should stop sharing your screen before I can share mine. Thank you very much. Okay. Please let me know if you can hear me and if you can see my screen.
We can hear you and we can see your screens.
Okay, so thank you very much. Okay, let me check. Sorry, before starting. Okay. So thank you for this kind invitation, and I hope I've been able to cover the elements that you have asked us to cover into this presentation about ECMWF. So of course, my presentation is to illustrate first what ECMWF as a research infrastructure is, but the examples that I'm going to present here are coming from a specific service that is the Copernicus Climate Change Service. So about ECMWF, who we are? Well, we are an intergovernmental organization. We have been established about 50 years ago, and we have different member states and cooperating states that work with us. We are an operational service 24/7, so our main focus is really delivering operational numerical weather predictions. And we are also research institutions, and these research activities are absolutely crucial because we need to improve our models, and we need, of course, research for this to happen. We also operate two European Copernicus services, and the one I will speak more about is the Copernicus Climate Change Service, because this is the examples that I would like to bring to your attention here. And other activities that are of special importance are that we recently worked in supporting early warning in Africa. But also we are largely involved in another program that is named Destination Earth. So I was mentioning the Copernicus Climate Change Service, and why am I focusing on the Copernicus Climate Change Service? Copernicus is the EU Earth observation program that use satellites in situ data, and actually the main scope is to really monitor our climate. And C3S, the Copernicus Climate Change Service, provides this authoritative information about the climate about the past, about the present and the future climate indicators, climate projections, really to support climate adaptation and mitigation. So what is very important in this context is that data are open, free of charge. And together with data, there are tools that really enable adaptation strategies. And finally, our main scope is really supporting policymakers and businesses. So C3S is a research infrastructure that, of course, has one of the main purposes is really improving European resilience to climate change. And in order to illustrate you how we fit as a research infrastructure into IRISC, into the IRISC context, I have decided to focus on these three key elements a bit around the slides. One is a very important focus on monitoring the climate. We need to do that because after monitoring the climate, we can get an in-depth understanding of climate change-related multi-hazard risks. And also we use these monitoring activities to interpret the climate that we expect will come in the next seasons, but also years and decades ahead. The second pillar is the focus on facilitating this evidence-based policy and decision-making. And I will go and navigate you via a few examples, mostly looking at these multi-sectoral climate services and risk-oriented framings. And of course, there is also the important element more on the infrastructure, on the data governance and the technological innovation that I will very briefly touch on. So, well, the starting point of all the conversation is that we are in a special situation when we look at our climate, and we need climate services really right now. Well, first of all, we see and we are experiencing an evolving climate, and we see more and more unseen events. And this sketch that you see into this slide that comes from one of the C3S authoritative monitoring activities illustrated the time evolution of the global temperature. Each point or each line in time is a year, and then you see the daily distribution for that year in colors. And in practice, you can see with the colors going from blue to red that, of course, temperature is increasing, and the distribution of temperatures is going toward a warmer global climate. We can easily see from this figure a couple of key elements. One is the fact that we have a shift toward a warmer climate, that we see a kind of an acceleration. There is variability from year to year. You have illustrated into these slides event like El Niño, La Niña. But there is also a special condition that we reached last year in 2025. This was the first year where none of the daily temperature was below the long-term average of 1991 and 2020. So the key message here is that we are seeing a moving of the climate, and we see an acceleration of this. And this connects to an acceleration also of the climate risks. These are a couple of snapshots just to give you an idea. First of all, we know that Europe now is currently ill-prepared for this new reality. Some time ago, we were saying, well, Europe is not prepared for what is coming next, but now we are saying we are not prepared for what we are addressing and seeing right now. Of course, these extreme events associated to the changing climate are also associated to strong impact from the economic point of view, and those have been, evaluated in different studies. And of course, also we see that from this World Economic Forum report on the global risks, we see that the top ranked global risks include all the environmental risks. So, what a research infrastructure into this framework could do? Well, first we need infrastructures that are policy enabling, and this is what I would like to bring in the conversation. This means that this infrastructure underpins implementation of EU priorities. The figure that you see on the bottom of this slide is a kind of an evolution of the number of different communication, directive, and regulations that include climate and Copernicus into the text, and this is growing over time. The C3S example as an ECMWF research infrastructure plays a role of being a strategic asset for competitiveness, providing trusted data, indicators, and services that support industry, finance, and public authorities to manage climate risks. And it is important to mention that there is this European Competitiveness EU funding instrument that is proposed really to support strategic sector and European industrial capacity. And to this extent, we have recently proposed and delivered a specific socio-economic benefit of some of the C3S data and products. So our infrastructure serves a lot of different data. One of the most relevant data is called global reanalysis, is in practice a reconstruction of the past climate. The figure that I was showing before was based on this product. And this is one of the most used product. And actually, this study illustrated and demonstrated the real benefit that this data set is providing into our society. Well, first of all, I would like to mention that the reanalysis per se uses millions of observations, and this makes really the case of highlighting and reinforcing this federating role of the infrastructure around the observations. But then, of course, the socioeconomic benefit tells us that in different sectors of society, having this data available really made a difference. Now, because I mentioned this reanalysis, I'm really happy, sorry, this is a technical slide to give, you can focus it even just on the plots on the left-hand side. An illustration of what this climate reanalysis is the reconstruction of the past climate. You can see extreme events and you can monitor them, for example. And you see that this product that is a very popular product, is something that also evolves over time. We are improving the product itself. We are increasing the resolution that is needed for looking at extreme events, for example, and we are improving the science behind. So we are going toward a better product. The next element is that as an infrastructure, we support European technological sovereignty, and this happens by integrating observations, supercomputing, and modeling, and also AI by serving our member state and citizens. And again, the case of the example of this reanalysis that I was showing is that now the reanalysis are the foundation of this AI revolution. We have AI-based model for example, weather forecast. And I would say that all of them at the moment are trained on this product, this global product that we are serving proudly at the Copernicus Climate Change Service. So the few examples that I wanted to use into the time that I have available cover different areas. The first example is about the climate monitoring. I mean, I started already mentioning the climate monitoring in the first slide with a time series. But actually C3S provides these regular authoritative climate monitoring activities, and we provide relevant reports and analysis of where we are with respect to a past long-term climate. This is an example of an extract of those reports. In this case, we highlight where year 2025 and year 2023 and 2024 sit with respect to this long-term climate. We can see that year 2025 ranks as the third warmest year on record, following this unprecedented temperature observed in 2023 and 2024, but also that 2024 remains the warmest year on record, exceeding this 1.5 degree temperature above the pre-industrial level period. Of course, we can take more look at the evolution of and the changes across during the year and across time. So we can see that the global temperature increases every month. Globally, the January 2025 was highlighted as the warmest January on record. And of course, those are monitoring the global climate. And we know that also those changes are observed into the European climate. So Europe is, of course, part of the globe. And Europe is warming at twice the rate of the global average and is the fastest warming continent. And associated to this increase in temperature, there are extreme events that are continuously observed. As the climate warms, more extreme events are seen. And this is an example of year 2024 that was not an exception. Of course, monitoring the climate help us also to see the fact that we are facing really unseen or unprecedented extreme events. If we think of this year 2024, for example, this was characterized by a terrible season in terms of wildfire in Portugal, where, for example, so many hectares have been burnt in 1 week, and this was like a quarter of the total burnt area for the whole Europe. So monitoring the climate is, of course, the starting point, is the baseline, and this is used to understand and to interpret what's coming next. And for doing so, we need different type of data depending on the timescales. We look at predictions and projections of the climate. I give you just a couple of examples and illustrations. The first type of data that we offer to look at the climate that is evolving is called seasonal predictions, seasonal forecasts that help us to look at the climates for the next season or for the next 6 months. In this case, we offer access to a multi-model seasonal forecast system. And this multi-model is built together and in collaboration with other research infrastructures. This is to highlight how ECMWF interoperate with other research infrastructures. This is just a snapshot and also illustrate an example of the forecast, for example, for the next months in terms of El Nino. Our model says that we are migrating toward a new El Nino phase for the next months. But we can look at, ahead, again, decades ahead, years ahead. And we can now start to take a look at different kind of predictions. In this case, those are called decadal climate predictions. We look again at the next years up to 1 decade ahead. And we can do this again by working together with other research infrastructure as a federation. And the output of these activities is giving access to different models data together in the same place, data, but also case studies across different sectors. And when we look even more ahead of time, we need to take a look at outlooks of what the climate could look like, the decades ahead up to the end of the century. And this is where we work with what we call climate projections, and we link and interface with the authoritative science behind the IPCC reports. And we link with the other infrastructure, adding layers of harmonized access to this kind of data. So the bottom line message of going across this type of data is that we are working here with different typology of data, and the infrastructure help to give an harmonized access of a variety of data, and also a quality control level on top of that. What we do with this data? Well, we can go a bit more downstream, and we can build services. And an example here is an illustration of a hydrology and climate service as a concrete example built on top of this data. So why and what is a water service? Well, a water service is built on data, and I've been talking about different kinds of data so far. Data comes from different sources. We do this huge effort of harmonizing access to the data, but the user's questions are often seamless in time. And they ask questions such as, what are the current hydrological and climate conditions, the climate today? What can happen in the next months to the same conditions? And what does the future in the long term hold? But these questions that needs different type of data to be answered are asked all at the same time. So from the user perspective, there is no difference across, the question is somehow a unique and seamless kind of questions. This is why we need to build a service that is harmonized in the answer, but with the data behind it, of course, to the possible extent harmonized. When we look at the current conditions, we need to work with the operational hydrological monitoring activities. When we look at the next seasons, we need to work with seasonal hydrological forecast. And when we look at outlooks in the longer term, we need to work with hydrological climate change projections. The first example is looking at this monitoring part of the service. So the service really works to give this harmonized access to the data and vision, both at the global and the European scale. So when we monitor the climate in this area and in this context, we want to answer questions such as, to what extent are water resources exposed to climate variability and climate change? And this is the kind of questions and the kind of answers that we try to give with data and visual products. Or can you give me an overview of the flooding across Europe in the current years and months? And what's happening next even? Well, can you say something about the next seasons ahead? Will the river discharge have a special behavior? Are we going to experience hydrological extremes, maybe droughts, a prolonged droughts? And if we can go longer in time, do we expect to have issues with water availability in the near and long-term climate scenarios? So this needs different ingredients to be answered. When we look at the next season ahead, as said, what we do now is that we make use of what I've presented in the previous slide, is this harmonized access to seasonal forecast climate information. And when we tailor it to the hydrological questions, so we try to really build a unified, harmonized framework in terms of data, in terms of tools that are applied to the data, and in terms of outputs. In this case, you can just see on the right-hand side, we give access to multimodal hydrological information focused on specific hydrological variables such as river discharge, runoff, soil moisture, and snow in a kind of a consistent manner to the possible extent. And the same we try to do when we look at the long term ahead and we want to look at the long-term outlooks of the climate. We start with this harmonized and quality control access to the long-term climate projections data. We use harmonized set of tools and we give access to data and visualizations to address the questions across these timescales. The next example looks instead at the finance sector, and those are the type of questions that we receive. So given that the climate is evolving, can we say something about my investment? Is my investment at risk? Of course, at risk when we look at specific climate hazards. This is an example of work that we are building with the European Investment Bank. And the European Investment Bank is this lending arm of the of Europe, and they invest money in these long-term lasting infrastructures. And a big fraction of the investments is about adaptation. In doing so, they need to adhere to legal frameworks, to regulatory requirements. For example, what you see on the right-hand side, the EU taxonomy legal legislation framework. And what we are doing together is trying to support society and the finance sector to answer these kind of questions by building this kind of standard climate service for the finance sector that is in line with the regulatory requirements, that is based on authoritative science and transparent processing, and it is responsive to user needs and new technologies. In practice, this corresponds to give access to process data that looks at this multi-hazard under the form of maps, but also under the form of a tool that help navigating the complexity of this information. Very quickly, as an example, the tool is something like a space where it is possible by selecting a specific economic activity sector and the lifespan of interest for the investment and a specific location to have an overview of the exposure to the different climate hazards as derived from the data that I was presenting in the previous slides. And this is a kind of a harmonized and standardized approach across the multi-hazards. Sorry, I do not have time to go too much into the details. Just to summarize, this is an example of a climate service that is built for the finance sector that wants really to support financial institutions, SMEs, project developers, everybody in the economy to find answers to this kind of questions. Where we are now is mostly focusing on this multi-hazard framework, and in the next phase, we will also work to cover other components of the systemic risk assessment. The next example looks more at the energy sector. That's, I think, my last sector example before I go to my conclusions. So why the energy sector? Where we know that Europe's power grid is interconnected. And in this case, the example is supporting the European Network of Transmission System Operators, this ENTSO-E named into the slide. This is a coordination of 40 operators, TSOs, Transmission System Operators, across 36 countries in Europe. And of course, these TSOs need to coordinate because the power system is interconnected, both at the regional, national, and cross-nation levels. And ENTSO-E has the mandate, among others, to provide reports on the adequacy of the system, of the electricity system in Europe, especially in the scope of its security. The key questions they need to answer are, well, what are the main risks to Europe's electricity system over the next 10 to 20 years? And they do this by providing assessment reports that I'm not going into the details right now to explain. But of course, the reports needs climate data. And this is the role of our research infrastructure and our climate service to provide this harmonized access to the data to answer these specific questions. Well, my last reflection is more on the infrastructure side that I've mentioned at the beginning. So we serve the users. This means that we go from big data ready infrastructure to a kind of unified experience. There are new technology coming. For example, we speak more and more of this cloud optimized and federated data access. This means that data does not need to move, but we compute, is the computation that moves where the data are. We mentioned technologies like this cloud native chunking czar that is in practice a way to scale or is a scalable distributed access to the data. We talk about smart methodology, smart data access or smart subsetting that helps to deal with cross-domain queries. But also very important is working in these unified dataset viewers, so having this common access layer. And this is what somehow a federation-ready infrastructure tries to do. We work our infrastructure in the Copernicus Climate Change Service is named the Climate Data Store, and this really acts as a centralized gateway to this information, harmonized metadata catalog, standardized API endpoint, and functionality similar to this federated service hub. Well, probably there would be a lot to say about that. Maybe I leave you with this. Yes, I have also reflection one, but I mean, my last but one slide is just to put all this material a bit into the context of the IRISC ecosystem. So I try to mention examples and to illustrate how ECMWF and the C3S infrastructure contributes to the topics that you see listed into this slide via the different examples. And my main reflection on this are these key bullets. Well, first, Europe is facing this accelerating climate risk, and we know that we are not yet fully prepared. We are talking about this record-breaking temperature, extreme events, economic damages. This demonstrates that climate risk is systemic, is immediate, is material. Climate services like the Copernicus Climate Change Service are enabling EU policy and competitiveness in this respect, with examples like energy security, resilience, sustainable growth. And actually, the idea is really to strengthen European strategic autonomy. We are facing also digital transformation that is accelerating climate risk management. And I mean, we have to take into consideration integration of supercomputing, Earth observations, modeling, cloud native data, and AI is creating this kind of capability that for the next decades. And finally, data governance is also very important. I didn't have the time to talk about this, but this is a very important ingredient in this conversation. And this enables this interoperability, scaling up, and my key message is turning climate data into public good. And I think I thank you for your attention.
Thank you very much, Chiara, for that comprehensive and complete presentation. As I said, we're going to keep the questions for later on. Without further ado, I'm going to give the floor now to Ville. Ville, the floor is yours.
Okay, thank you. I'll share my slides at the first place here. Okay, and I think now you can see my slides, correct?
That's correct.
Okay, so yes, good afternoon, everyone. My name is Ville Tenhonen, and I'm working for EGI Foundation. And well, a short agenda for this presentation is that first, short introduction to EGI and EGI's contribution in the IRISC project. Then some words about access management support and integrations with D4 Science, and then a little bit about EOSC integrations with the broader EOSC ecosystem. Then we have a training support in the IRISC, also some words about that, and then a little bit general information about our technical services and so on. But yeah, short introduction. That EGI is shortly saying we are this kind of pan-European e-infrastructure. We are supporting different research infrastructures in many ways. And well, basically, we are doing this working with the computing data and application and federation environments is our nature. And EGI itself is also a federation in Europe. We have a council. Council members are coming from 21 countries. They are also members of the EGI. EGI have a history in physics and this kind of grid computing, and our former name was European Grid Infrastructure. But nowadays we are doing in many disciplines and supporting different kind of areas of the science and so on. So we are not, and the grid computing is not nowadays, how can I say, mainstream, and so on. If there is some grids anymore, there is some, but they have a minor role in the Europe right now. But we are doing different kind of cloud computing and data continuum and sharing application layers and so on. And of course, there is an innovation and knowledge exchange, and interoperability and standards are very strong in our picture. Yeah. Okay. Here is some picture about our those research infrastructures which are participating with the EGI. We have a memorandum of understanding, and we are working with the SLAs, service level agreements, with a number of organizations. We support in different projects several different research infrastructures all over Europe, and we have a different level collaboration in with a number of different. I think that very familiar, very familiar in research infrastructures also. Yeah, some numbers. These numbers coming from not last year, but 24. Well, more than 100,000 users, and we have supported infrastructures which created almost 3,000 papers per year. 2 exabyte of data went in our federation, and in total we have worked with the people from 170 plus countries. We have a memorandum of understanding and collaborations also outside Europe, even if we are European organization. EGI contribution in IRISC. We have a few work packages, and we are leading work package number 1, communication, dissemination, engagement, and exploitation management. Magdalena Bruce, she's a liaison of this work package. Then we have also those training services and knowledge exchange, and we are contributing to a couple of tasks there. Ian Chen and Elia Belussi, they are our experts in this area. And then harmonization and technical interoperability work package 6, and here is those access things and process policies and procedures, and I am the liaison in this work package, and we have also contributed in work package 7 with the catalog of services, and that's also, I'm also contact person for that and so. Okay. let's go to the access management AI support and the integration with the D4Science. And this is gives a one picture of what we are doing with the projects and in research infrastructures. What is this we are doing? What is this federated AAI solution and architecture? AAI means this authentication and authorization infrastructure. And basically, it means that users who are working for ERISE research infrastructures can have access to some resources of the project or some general and some resources from some other research infrastructure. And this is this kind of federated model where we have standards coming from this AARC project, and we are following these blueprints and so on. EGI have our own product for these solutions as a technical federation solution called a EGI check-in. A little bit more about that one. And the basic idea is pretty simple. It goes that way that users can log in to the services with their own credentials, meaning that, for example, in the university, they have university accounts. They can use this university account to log in different kind of services. And that does not mean that, for example, passwords or any other information comes from this kind of secret information comes from the institution to the EGI check-in and so on. We got the SML tickets there, and this is the way how does it work. And this means that there is when you log in into the EGI check-in, which is a proxy service, meaning that there could be the several different kind of services from D4Science, from other ERISE or EGI Federation somewhere else, which gives an access to those services for your account, which is based on your own credentials from your home institution or these social IDs and so on. So basically, you can use your own ID to log in to the all federative services of the IRISCC when we are ready with this. This is a basic idea, and of course, technically, this picture is a little bit, how can I say, not so simple, and I don't try to explain it all here, but it requires some technology behind all these functionalities. But the basic idea is like that. For example, some number of universities, they have their own internal federations, and in principle, this is a little bit similar, but it goes wider and it's a European-wide arrangement. ERA integrations, what we are doing here right now, we have discussed with plenty of different ERAs, and also this IRISCC catalog, which is a catalog of those resources and services for IRISCC, which is a very good and important service. Also, something what we have done already is that earlier that we have D4Science, which gives the computing service, and there is, for example, notebooks for creating codes and running some applications and so on. And we have also integrated that one in with the EGI check-in, meaning that you can go without any kind of obstacles from your own organization to these services if you have logged into the EGI check-in. ENRIHub Next is another project, and there we have done also these things. So there is this kind of, it's not a sister project, but another project in the environmental sector, and it makes it easier to jump from the one project to another project resources and collaborate that way. Something which is a little bit coming to the IRISCC is this European Open Science Cloud. A couple of words about that a little bit later. And then, of course, those wider possibilities that EGI have in its own federation, we have pretty wide EGI check-in integrations, meaning that there is a possible services in different places and so on. Idea is to get all these resources to researchers as easy as possible. Okay, about this European Open Science Cloud, which is very important for EGI. We are working in a number of the European Open Science Cloud related projects, and we are coordinating some of them. If it's not familiar to you, European Open Science Cloud is a European Web of Fair Data and Related Service for Research. That's this kind of traditional one-liner about that. And the basic idea is to unlock full potential of research data and accelerate discoveries and innovations. Meaning that the idea of the European Open Science Cloud is to open and remove the obstacles to data usage in the Europe from different kind of research infrastructures and other resource and data sources. And this is a European Open Science Cloud is a very big project also, and there is organizations and so on for that. And the basic idea currently nowadays, European Open Science Cloud has organized by nodes. And nodes means that, okay, they are run by some organizations. There is currently 10 nodes, and next wave is coming that there will be, I don't know how many, 12 more or something like that. No decisions yet about these. And basically those nodes, which include those computing resources, data resources, all kind of applications and so on. They could be thematic nodes like for the climate change or sea research, ocean research and so on. There is some of these, and health data sector, they have their own thematic nodes and so on. Then national nodes in some countries have already national node, which gives this kind of multidisciplinary services, and so regional nodes, and then European level nodes like EOSC EU node, which exists already. And EGI is one of those service providers there. And well, in the future, these nodes are also networking with each other and sharing different kind of capabilities and resources. It's a very big project to get everything up and running, and currently it's going forward pretty nice speed and so on. But again, it gives the open access and possible access to different kind of resources, and there is a different kind of technical methodology to do that. Meaning that in IRISCC project, we have a task 6.6, and the basic idea is that, okay, we are creating some services and resources in the IRISCC project also. We should integrate them into the EOSC. And in our proposal, it says that, okay, we should create the exchange with the EOSC marketplace. But unfortunately, during this period from the writing the proposal and nowadays, this marketplace has been removed. So we have to a little bit make a new architectural consideration with those nodes and check that, okay, how to deal with them. But this is coming. Training and support in IRISCC, EGI has delivered some of these already. Basically, EGI's trainings in general, we have a FitSM trainings and we organize that. It's a FitSM, I have one slide about that a little bit later, but it's about IT services, all services in general, and it's a standard to manage those services with a pragmatic way. ISO 27001 training, it's about information security management, and it's a little bit related with the FITSM also. And then we are delivering also training infrastructure. If there is some dedicated trainings for some purposes, we can organize computing storages and these kind of things for training and education. FITSM, it's also related with the IRISCC project, and it is lightweight standard for IT service management, how to create these things. And well, it's this kind of common conceptual and process model, meaning that standardizing activities in the service management makes some accountability and traceability a little bit better, and making things easy to manage, and making this kind of administration a little bit working a little bit better, and so on. FITSM is okay for the projects and infrastructures and so on. Okay, I think I can skip that one, but there is FITSM is a standard with the qualification program, and starting day, 1 day foundation training is something which is a good place to start to think about this kind of service management things. This is the last part of my presentation, and pretty fast that one. EGI is creating services for research and federations and businesses. And okay, it was that way. For the research, we are doing computing, cloud computing, containers, high throughput compute, and a software distribution. We have a computing orchestration and applications like notebooks in different services like a D4Science. Storages, we have a data hub service for sharing and storing scientific data in scalable way. Data transfer for big data sets, and online storages for to do things with computing and so on. We can create a dedicated environments for the project. Check-in is one identity service, and secret store is a pretty new service to store different kind of secrets as API keys and these kind of things. And those training services I mentioned already. And yeah, we are starting to reach my last one, but how we are engaging with the communities. Basically, we have EGI is a federation of different kind of service providers, and there came some conditions that they have some rules and conditions how they can share the resources and services and so on. And then we have a communities which have a requirements, meaning that okay, how much researchers requires data or computing power and so on. And EGI is a negotiator, and getting those requirements and conditions on the same page, and creating actually two kind of documents: service level agreement with the communities and operation level agreements with service providers and so on. So we are one kind of node between needs and services and resources and so. We are dealing with areas and projects and some institutions also, but anyway, we have a number of different ways to this kind of payment things and so on. What kind of financial requirements there is and so on. There is a number of these arrangements and so on. But yes. Yeah, we have this kind of access call which going on, and basically is to offer our services and resources and so on for those organizations and areas who needs them. And there is a ongoing application which is open all the time. And yeah, there is a different kind of sponsoring methodologies and so on. Free to access for the use cases and select it through this call. So if you have a suitable use case and some needs, well, please check if EGI can help you. Thank you.
Thank you very much, Ville. That was a very comprehensive introduction to EGI, and it was very easy also to see how EGI is fitting in the IRISC consortium. Once again, I want to thank both of you, Ville and Chiara, and also all the participants that were attending today this webinar. Before moving to the questions, I want to remind you that we do have still some upcoming webinars in relation to the research infrastructures. In 2 weeks' time, we're going to have the EMBRC and the CDataNet. So that session is going to be a bit more oriented towards the marine hydrosphere. I also want to encourage people to go and check in the IRIS website, the catalog of services that Ville was explaining. There you can find the different services that IRISC sponsors from the different 14 research infrastructures. And in relation to that, I also want to say that last week, IRISC opened its third transnational and remote access call. So if you go through the catalog of services, you find that there are some services or some experiments that would be beneficial for your research questions. Now it's the time. IRISC can actually sponsor those services in case you need to go to physically or remotely to some of these facilities. Just send a proposal. You will find information in the website, and the call is going to be open till late April. So once again, thank you all. At this point, I'm going to stop the recording and we are going to move to the questions.